Why is it so slow to develop a new airliner nowadays? How did we go from developing an all-new jetliner in 3 to 4 years back in the 1950s and 60s to needing more than a decade in order just to change the engines and wings on an existing aircraft today? Can we actually continue like this? I mean, how are airlines even supposed to know what they need if the new planes won't come for another decade? Well, stay tuned. A few weeks back, I looked at the history of the fantastic Douglas DC-9, and in that video I happened to mention that the previous jet, which Douglas had made, the DC-8, went from launch to revenue flights in just 4 years back in 1959. Now, that was a huge deal, because for Douglas, the DC-8 wasn't just a clean sheet new design, it was also their first ever jet aircraft. On top of that, 6 months after that first flight, Douglas was already producing 8 DC-8s per month, which showed that they had in that record time successfully transitioned from producing an aging family of piston engine airliners over to the jet age. Now, in the end, Boeing would eventually sell more 707s than Douglas ever did with the DC-8, but it was still a good effort and a reasonably successful aircraft. Not a bad recovery for a company who effectively gave away the lead in the jet age to Boeing. Anyway, the point that I wanted to make with that story was that the development of the DC-8 was super fast, and generally speaking, we should be getting better and better at designing complicated machines over time thanks to technology and experience, right? Today, we have the use of powerful computers who will allow a single person to calculate stuff in a few minutes that used to take a room full of people a whole day back in the times of the DC-8, and that doesn't even take into account how quickly we can now just change a few variables in our calculations and instantly get new results back. Today we also use global networks who allow the world's best minds and computers to speak to each other in order to double check each other's work while designing and testing literally anything that we can possibly dream about. And still, if we take a quick look at how long aircraft development took in the past compared to now, we can see an unmistakable trend, and it doesn't look like we're getting any faster. Here's a simple graph, just to show you what I mean. In 1958, Boeing's 707 went from program launch to carrying paying passengers in just 3 years. Then, with the exception of the DC-8, every other major airliner of that era took under 4 years, including the very first wide bodies, the Boeing 747 and the McDonnell Douglas DC-10. Now, I know there are some caveats to these numbers, for example that the 3-year development of the 707 doesn't include the build of Boeing's 367-80 prototype, and also in between that and the 707, Boeing was also developing the KC-135 aerial refueling tanker for the US Air Force. And similarly, the 727 borrowed a lot of design from the 707. And the same also goes for the 737, who benefited a lot from the 727 and the 707 designs. On top of the times shown here, there is also a lot of development work that could take place even before the official launch of a new airliner, and different manufacturers might do these things slightly differently, making true comparisons very difficult. But there's no question that development is just getting slower and slower. From the late 1950s until around the early 1970s, a 4-year development for a new aircraft seemed like a reasonable target to have. Even the technologically advanced Lockheed L-1011 TriStar would have taken less than 4.5 years if it hadn't been for some problems that they had with its brand new Rolls-Royce RB211 engines. Still in the early 1980s, Boeing didn't stray far above 4 years with the development of the 767 and the 757. And similarly, Airbus certified the Airbus A320 in just over 4 years after its launch in 1988. But then they took about 6 years to develop the Airbus A340 and even more for the Airbus A330. But as late as in 1995, Boeing launched their majestic 777, at the time their second largest aircraft, and the development took just 4 years and 8 months, which was pretty amazing knowing that this was their first ever fly-by-wire aircraft. But after that, something changed. Despite a super long pre-launch period of around a decade, Airbus followed up by taking nearly 7 years to bring the admittedly gigantic Airbus A380 to service. And Boeing, who wanted to launch their brand new 787 even faster than they had the 777, ended up needing 7.5 years to get it certified after its launch. And that time doesn't include later groundings and delays because of problems with batteries, engines and various manufacturing defects with it. But like I mentioned, Airbus wasn't any faster, with their Airbus A350 needing even longer than the 787 had, just over 8 years to get certified. And Bombardier, a much less experienced manufacturer, also needed around 8 years to develop their C-series, which we now know as the Airbus A220. Now, once again, there is a lot of nuance to these timelines, including delays outside of the manufacturer's control, and sometimes the manufacturers just took a little bit of extra time with one aircraft because they were prioritizing another, like Airbus did with the Airbus A340 over the Airbus A330. But the question still remains, why is aircraft development seemingly slowing down? Why will, for example, Boeing's 777X, which essentially is just a 777 with new engines and a new wing, take 13 years to go from launch to carrying passengers, over twice the development time of the original 777 itself? And what impact will new engine technologies have on all of this? Is there a possibility that the aircraft manufacturers might have some trick up their sleeves to trim the development times down? Like I trim my beard with the excellent Lawnmower 5.0 Ultra from today's sponsor, Manscaped.com. With this trimmer, you can reach true precision with its dual skin-safe blades, who uses longer, wider and rounded teeth for that effortless perfection, and the foil blade for those precise finishing touches, like a Swiss Army knife but for all of your grooming needs. It's also perfect for traveling with its 3-hour battery life, USB-C charging and a handy big USB dual temperature light which perfectly illuminates the area that you want to groom. Awesome! I really recommend the Performance Packet 5.0 Ultra Kit, which includes the Weed Whacker 2.0, their waterproof awesome nose and ear trimmer. And if you use my link here below, which is manscaped.com/mentor now, you'll get 20% off, free international shipping and 2 free gifts when you get the Performance Packet 5.0 Ultra. That's 20% off, free shipping and 2 gifts when you use the code Mentor now. Trust me, your parts will thank you. And speaking of parts, the first reason for the increase in aircraft development time is something that I'm sure that most of you have already guessed. Simply the stricter certification standards that we have today regarding both parts and aerostructures. And to illustrate just how influential these changes are, let's look at an extreme example, and a super simple one at that, the Cessna 408 Sky Courier. This twin turboprop entered service in 2022 and was developed from a clean sheet design, and with all due respect to Cessna and Textron, who own Cessna these days, the Sky Courier probably won't go down in history as the world's prettiest aircraft. But it turns out that there is a really good reason for its boxiness. There is a passenger version with 19 seats, but the real reason Cessna developed this plane in the first place was for cargo transport. The Sky Courier was designed to carry LD3 cargo boxes. You know, those boxes that wide-body airliners and also some narrow bodies fit into their cargo hold to carry passenger baggage and freight. Cessna designed the fuselage of the Sky Courier to fit 3 of those LD3s, and that they did at the request of their launch customer, FedEx. The idea was that FedEx crews would be able to unload LD3s from larger airliners and then quickly just reload them onto the Cessna without having to rummage through and resort all of the cargo, which is pretty clever. But crucially for this video, that was the only true innovation in this aircraft. Beyond that, its layout and parts are as conventional and simple as they come, which was by design. It uses a non-pressurized, conventional aluminium airframe, fixed landing gear and 2 proven Pratt & Whitney Canada PT6 turboprops, whose design actually dates all the way back to the 1960s. So, knowing that, how long do you think it took to develop that aircraft? 4.5 years, which is about the same time that it took to develop the Lockheed 1011 back in 1972. Okay. Cessna was developing the Sky Courier during the pandemic, which of course didn't help. But remember, Lockheed's L1011 also had a lot of time added to its design because of those engine delays that I mentioned before, so that's not really a valid excuse. Now, the main reason why these completely different aircraft took so similar times to enter service has to do with how the certification standards has changed in the 5 decades that separate them. In an earlier video, I explained that today an aircraft manufacturer like Boeing needs to use around 1,500 people who also do certification work on behalf of the FAA. These employees are called ODA designees and are still on Boeing's payroll while still working essentially for both Boeing and the FAA. Now, there is a lot to say about Boeing and their relationship with these employees, but the point here is that these days, having that many people involved in this kind of work, both before and after an aircraft certification, really is completely necessary. And Airbus, by the way, has a similar setup with EASA, which is the European Aviation Safety Agency. The reason for all of this scrutiny has to do with the safety-related lessons that the industry has learned over the years. We often say that aviation safety regulations are written in blood, and that unfortunately is literally true. Over the decades, the investigations of nearly all accidents or serious incidents have generated multiple recommendations, and those were all made with the aim to making sure that similar accidents or incidents wouldn't happen again. These recommendations don't necessarily have to do with the aircraft itself, but many actually do, and assuring that any new aircraft actually meet them and that those aircraft are made from the correct parts in the right way and so on is a kind of moving target for both regulators and manufacturers. That's something that the FAA apparently got a little bit wrong in previous years in terms of their oversight of Boeing, which then caused a lot of changes after the two 737 MAX crashes in 2018 and 19. And that obviously had an immediate knock-on effect on the certification work of the remaining MAX variants, and also of those extreme delays in the certification of the 777X, which I mentioned before. Now, sometimes we see the effect of these tightening safety regulations in some quite unusual ways. In a previous video that I made, I looked at the new Air Force One project and the problems that Boeing are facing when it comes to preparing those newer 747s for their new role. You see, even though these jets will technically be military, the US Air Force still decided that they should also follow the FAA certification and safety regulations for brand new aircraft types. And that fact presented Boeing with a really unexpected problem in the form of electrical wire bundles. You see, it turns out that over the years, the FAA has tightened regulations on how close different wire bundles can be placed next to each other. If, for example, an aircraft has 3 redundant systems who perform the same function, well, then the wiring of those different systems should ideally follow completely different routes. If you think about it, that makes sense, because that means that if something damages the wiring of one system, the other systems won't be affected. And these type of new regulations is a perfect example of things that have evolved to become more stringent over time. But newer versions of older aircraft types, like the newer 747s, are typically allowed to continue being built according to the older rules. That's something known as rules being grandfathered into these newer aircraft. But when the US Air Force asked Boeing to make sure that they satisfied current FAA certification requirements for the new VC-25 Bravo, which is the next Air Force One, this meant that Boeing had to rip out hundreds of miles of wiring in order to reposition them, according to these newest regulations. And of course, on top of that, the Air Force also had added several more systems that needed even more wiring. And that's just one example of certification requirements and how they become more and more detailed and demanding over time. And together, these rules are all slowing down development and certification of all new aircraft. This is of course also extremely costly, but as the expression goes, if you think safety is expensive, try having an accident. But that's not all. Ever-tightening regulations are only one reason for the increasing aircraft development times right now. Another obvious one is the fact that modern aircraft are also incorporating increasingly complicated systems. Now, note here that I'm referring to the systems themselves, not the way that they're presented in the cockpit, which is thankfully getting sleeker and simpler for every year that passes. But the increasing system complexity overall means that aircraft designers, engineers and test pilots also now need to consider anything that could possibly go wrong with all of these various kinds of systems and automation, especially if 2 or more systems happen to fail at the same time or interact with each other in unsuspected ways. A relatively recent example of this is the panic that was caused by the introduction of 5G masts near airports in the US about 2 years ago. Now, That's a long story, but the key point was that under certain circumstances, 5G phone signals could interfere with the radio altimeters on board certain aircraft. That in itself was a notable risk, but what made it even worse was that some aircraft used the radio altimeters in combination with other systems, like the weight-on-wheel switches, for example. And what that meant was that these problems with the radio altimeters for some aircraft had many more implications, which could severely limit their performance under certain conditions, like landings or takeoffs on wet runways, for example. Of course, it is possible to mitigate these type of problems, for example if they're discovered after the aircraft type has entered service, but these mitigations required new procedures or sometimes costly modifications to existing systems, which by the way is how the 5G problem was eventually solved. And the need for those type of changes is another reason why the regulators need so many people to continue doing certification work even on aircraft that are already in service. Now, new composites, improved metal alloys and new construction methods for new and old materials all add to the long list of variables that manufacturers and regulators now need to test and approve before an aircraft can actually be certified. And in the last few years, the design and certification of aircraft components have gotten even more complicated, since the design and certification also have now started to involve more and more different suppliers. For decades now, Boeing and Airbus, for example, have used computer programs to build a complete, highly detailed virtual copy of the aircraft, complete with all of its millions of parts down to the last rivet. This is obviously done to avoid nasty surprises when the first aircraft are built, and also to help designers to determine other parameters like making sure that the aircraft has the right weight and center of gravity. But the modeling isn't done just to make sure things fit with each other. Software is now clever enough to run simulations of the various parts and systems, for example to verify that ducts and pipes have the right diameters. And if you're interested in learning more about these clever tools, you should definitely check out Björn Färm's series on aircraft technologies over on Liham News. It is excellent. But the problem now is that the manufacturer of a particular aircraft doesn't actually make all of its components themselves. Many suppliers don't just build parts to the manufacturer's specifications anymore, they also design and certify those types independently. What that means is that the manufacturer now needs to engage other companies very early on in the detailed design phase, and sometimes even earlier than that, often before the aircraft is even officially launched. And engaging these suppliers increasingly also means things like making sure that they're using the same digital design tools and that they're using them in the same way, all of which is easily said than done. Now, in theory, if these clever design tools work, they should eliminate nasty surprises and therefore reduce development times, and that is why all aircraft manufacturers are now trying to use more and more of them. But unfortunately, making all of this happen in practice isn't very easy. Boeing and Saab are currently working together with this type of digital tools to build the T-7 Red Hawk trainer for the US Air Force, which should allow them to assemble components manufactured continents apart in minutes instead of hours. But scaling up that technology so that it will work for airliners with their millions and millions of parts, it's a much, much bigger challenge. Even the T-7 program, which was supposed to be an easier way to test these technologies, is currently facing very long delays. Speaking of military programs, by the way, it's worth pointing out here that, if anything, military aircraft are facing even more extreme development delays right now than the civilian airliners do. Some of them are now taking well over 2 decades to be fully operational and in service, which means that by that time, when they're finally ready, whatever role that they were originally designed to do is probably already obsolete. The fact that they might become obsolete is a factor for airliners as well, because if the development is taking too long, it might risk making new aircraft completely irrelevant to their intended market. If you think, for example, an airline that decided to order a long-range, single-aisle aircraft to fly long-haul routes might find out years later that some extra space in the hold for cargo is getting more and more valuable, which could end up making that initial purchase completely uneconomic. So to recap, aircraft development times are right now going up because of increasingly complex regulations, increasingly complicated aircraft and aircraft systems, new lightweight materials requiring new manufacturing processes, more suppliers doing more and more design and certification work. But finally, there's also one more thing, perhaps the biggest variable to influence the development time of new aircraft, and that's engine technology. Björn Färm is currently doing an engine development series over at Leham News, and one of the key points that he's raising is that as crazy long as airliner development times are today, jet engine development actually takes even longer. Now, of course, not all new jet engines are clean sheet designs, in fact, most aren't, but the point is that new and super efficient engines are often the very reason that a new aircraft needs to be developed in the first place. And this means that sometimes aircraft development has to actually wait for these new engines to arrive. Jet engines are responsible for the vast majority of efficiency improvements from one aircraft generation to the next. So this can favor upgrading an existing aircraft with new engines instead of developing a clean sheet design, as both Airbus and Boeing have done on several occasions. But sometimes new engine technology requires an airframe of a completely different design in order for that engine to work properly. I've shown you before how both Airbus and Boeing are right now working on new concepts that could take advantage of the unique CFM RISE open fan engine when it becomes available. I will have to come back to that engine and other related developments in a different video, but for now, Airbus and Boeing are both developing their aircraft design tools so that they will be ready to launch those next projects as soon as there is an engine ready for them. And that is the real joker in the pack. Picking the right moment to launch a new aircraft is crucial. Launch too late, and the competition will use the new engine technology and beat you to the market. Launch too early and you might have to wait for the engine design to mature, paying thousands of designers and engineers to just twiddle their thumbs in the meantime. In practice though, being a bit late is probably the better option if it means that you can make sure that your design will be more efficient, because if you can, that's a benefit that as a manufacturer you can ride on for decades. But what do you think? Will Boeing and Airbus manage to reduce the time they need to bring a jet to market? Let me know in the comments here below. Now, my team and I spend loads of time painstakingly researching and making these videos. And if you like what we do and want to support it, the best way of doing so is by joining my Patreon crew, by clicking on the links that are here on the screen or in the description below. We have regular Zoom hangouts, which are great by the way, and you also get to preview all my content and really take part in the work that we do. So I would love to see you there soon. Have an absolutely fantastic day wherever you are, and I'll see you next time. Bye-bye.